Hello everyone, now we are going to solve the questions based on the balancing. So in this question, what is given? If the plane of rotation of the three masses are parallel, then the balance mass B1 is. We have to find out the balance mass. First you have to see which type of balancing it is. Is it static balancing or the dynamic balancing? In order to find out the types of balancing, you must understand the definition, the criteria for the static and the dynamic balancing. I already let you know in the topic that in the static balancing, all the masses are rotating in the same plane. Okay. Whereas in the dynamic balancing, all the masses are rotating in different plane. Okay. So it is given in the question that if the plane of rotation of the three masses are parallel, it is not saying that all the masses are rotating in same plane. Here, the plane is not same for the three masses. However, it is parallel, but it is not same. Okay, so we have to apply dynamic balancing. So that means it is an example of dynamic balancing. And in the dynamic balancing, we balance force as well as the moments in order to calculate the dynamic balancing. Okay, so here we can see here there are B1 mass is not given and B2 mass is not given. Okay, so we can take a moment. Let us assume that this is A point, this is B point, and this is C point. Okay, so you can take because we have to find out the balance mass B1, so we can take moment about point C. Okay, so taking moment about point C, you can calculate the B1. Taking moment, taking moments about B2. Okay, you can say about C because the point is C. Okay, so here B1 taking moments about C means moment is what? Moment is force multiply distance. Okay, this is perpendicular distance basically. So here the force is centrifugal force and force is mr omega square. Okay, so for B1 is I'm taking it as 1, that is B1. B1 is a mass. What is R? R is 40 centimeter. Okay, either you can convert it into meter or you can put it as centimeter, but you just have to careful about the units must be same in the equation. Okay, so I'm just putting it as it is mr omega square. Omega is not given. Okay, we will see whether it is required or not. And similarly you can apply the force F2. Centrifugal force is this, where 16 is the mass and R is 50 centimeter and mr omega square. So we can take the moment now. So for the F1 is B1 R omega square, and we are just taking moment, so moment would be 75 plus 50. The distance from A to C is 75 plus 50 is 125. 125. Now it is making anti-clockwise direction. Okay, when you take moment it would be in anti-clockwise direction, and when you take moment for this force it would be in clockwise direction. So I'm just considering anti-clockwise as positive, clockwise as negative. So it would be 16, 50 omega square, and what is the distance of this? 75. 75. Okay, so basically it is equal to 0. From here you can see that omega is not given and it can taken common, so basically you can neglect it by taking common. So from here you can calculate the B1 value. It would be equal to B1 is equal to, you will get here 16 multiply 50 multiply 75. It is just a mathematical calculation now. 40 into 125. So solve this, you will get the value of B1. So you will get B1 is equal to 12 kilogram. So that is the final answer for this question. Okay, so I hope you will understand the solution of that question.